Assalamualaikum warahmatullahi wabarakatuh. My name is Harith bin Ismail, and today I'll be presenting about my Arduino project, which is height measurement system. For the first slide, we have the problem statement, which is that height measurement is not considered as important. What I mean is that it has long been ignored because people just do not care about their own BMI. That is important to see whether they are obese or not, and this can lead to health complications. This ignorance has been amplified due to COVID-19, in which people only care about taking care of their SOPs and work online. This causes many places such as homes or offices to not provide the proper height measurement equipment. Sometimes the equipment itself are broken and not accurate, that can cause discrepancy in the final calculation of the BMI of the user. That is why we need a proper height measurement equipment. For the second slide, we have the circuit design, which is where I use Tinkercad. And there are some discrepancies in the circuit design itself because Tinkercad did not have all the components that I used for my project. So I had to substitute with what comes close to it, and the corrections are as follows. The Arduino Uno R3 board should be replaced with an ESP32 board that I use. The power and ground pin of ultrasonic sensor is connected to the breadboard as usual. Trigger pin of ultrasonic sensor is then connected to pin D14 on ESP32 board. Echo pin of ultrasonic sensor is connected to pin D13 on ESP32 board. LCD 16x2 should be replaced by MAT72198 by 8, or also known as dot matrix of 4 panels. The power and ground pin of the dot matrix is connected to the breadboard as usual. The IN pin, or the input of data pin of the dot matrix, is connected to pin D26 on ESP32 board. The CS pin of the dot matrix is connected to pin D33 on ESP32 board. And the CLK pin of the dot matrix is connected to pin D25 on ESP32 board. For the next slide, I will be explaining about the code that I have done for my project. For here we have the Arduino coding, which is done in Arduino IDE. And for the first picture, I have the include section, which is the management of the libraries, and the alien libraries here are MD Parola and MD Mat72XX, which is both used for the dot matrix visuals. Next, we have the constant variables, where I declared my Wi-Fi connection, such as the SSID, or the name of my Wi-Fi, which is in this case is my resident 2.4, the password of the Wi-Fi, as well as I have also included the server where I hosted my website, which is in this case Harith 123.1231.000hostapp.com. For the next one, we have the define section, which is where I define the hardware type of the dot matrix, which is in this case MD Mats 72SS F616_HW. I have also declared the pin locations of the dot matrix, which such as the data pin on pin 26, CLK pin on pin number 25, the CS pin on pin 33. I have also put the max number of devices as 4, as the dot matrix itself is consisted of 4 panels. The scroll speed to be 70, which is the speed of the text, as well as the scroll pause, which is the pause after finish displaying messages. For the next one, we have the MD_Parola P equals to MD Parola hardware type, data pin, CLK pin, CS pin, and mass devices. This is the arbitrary output pins of the dot matrix. For the next picture, we have the text effect, scroll effect, and text position scroll align, which is just the visual effect of the dot matrix from right to left. I've also declared the variables for ultrasonic sensor, which is trig pin to pin number 14 and echo pin to pin number 13. I've also declared variable for test string, height string, which is just 0 for now, as I'm going to use it to display other information later on. The duration of the delay, the distance, as well as height. I've also equipped Wi-Fi client to connect my project to the Wi-Fi. Next, we have void setup. First, we begin the connection to the connection between the board to the Wi-Fi. So Wi-Fi.begin SSID password. I've also included a loop here where if the Wi-Fi is connected, we will print it will be print successfully connected to the Wi-Fi network on the serial monitor. If not, it will just display connecting to Wi-Fi on a loop. For the next picture, we have void loop, in which I have also included the measure function, where I've done a simple calculation of if the distance is greater than 60, it will then display the text height from in the middle of the dot matrix. And if it detects an object below the sensor, it will minus the total distance between the object and the sensor and subtract it from 190, which is the max value of height that I have included in this project. So height is equals 190 minus distance, which is the distance between the object and the sensor, and height string is equals to string height plus centimeter plus cm. So the data will be shown as, for example, maybe 170 cm and so forth. Serial.print data date time is used for the printing of the data to the Excel sheet using the PLS deck, and display text string is to display the information to the dot matrix. Next, we have the string post data, or the connection to the server part. So here we have the if client.connect server, client.println post index, client.println host Harith, client.println content type, content length, post data, and post data, as well as serial.println connected. These are all codes to connect to the server. For example, here I have the post index.php, which is the name of the file in the server file management, and the host that we'll be connecting to is the harith123.131.00webhost.com. It will print the content length as well as the data itself, where here I have declared the post data is equals to height and height plus string. So it will be height, for example, maybe 170, and height string is 170 cm. If the connection failed, we'll just say failed to connect. And finally, we have the function void measure, where I've declared the digital write trig pin low for 2 microseconds as well as trig pin high for 10 microseconds. And the duration of the pulses is equals to pulse in equal pin high, and the distance is equals to durations times 0.017. Next, we have the code on the server side, which is also called as the PHP side, where I have declared hostname, username, password, and DB name. Hostname is localhost, username is in this case over here as shown, as well as the password. The DB name is the name of the database that I've used in PHP MyAdmin. Now, in order to connect, I have included my SQL command, which is mysql_connect, hostname, username, password, and DB name, or if the connection failed, we just say die connection fail. I've also declared the default time zone to be Asia Kuala Lumpur, the time to be hours, minutes, and seconds, the date to be year, month, and day, and all of the data is being printed to a file named temp.html. Also, the data itself is being posted live using the _post method to the server itself. And the SQL command is insert into height_data, which is the name of the table, date, time, height, with values being date, time, height as well. And if the connection is successful, or if the SQL command is successfully executed, it will put the data into a file named temp.html and display on the host web server. And that is my code. And here we have the testing result, in which where, as you can see, I am standing below the sensor and it detects my height as 182 centimeters. And for comparison, I have done a manual calculation using a tape measurement, and my height is 181 centimeters. So the discrepancy is only 1 centimeter, which can be pretty accurate. And here we have the video that shows me waving my hand in front of a sensor, in which the sensor detects it and tells the height or the distance between my hand and the sensor itself. So for conclusion, this project could be beneficial for those that are trying to measure their own height or someone else. It is relatively easy to do this project if you have the proper knowledge to do so. This project can be improved by those more experienced, as this project is open source. In good spirit, this project has been proven to work well under a typical household where the data can be seen live while simultaneously being sent to a database for later use. The data can be used for BMI calculation to keep track of a person's fitness and health, which is very beneficial since nowadays everyone's movements are limited due to the lockdown. This could lead them to not taking care of their diet and health. This project aims to prevent that, as well as the ignorance of people being unhealthy. In the end, this was a very fun project to build, as well as full of lessons and knowledge about IoT that can be used in further projects. That involves hardware and software to work in harmony, especially on the coding side. That is all from me. I would like to thank you very much for the experience, as well as the knowledge that you have given me, madam. And that is all. Assalamualaikum warahmatullahi wabarakatuh.